Hi guys, welcome to Sabonzi Academy. In today's video, we'll be solving the question 5 of the 2019 WASSCE Core Maths Theory questions. So we begin with question 5a. A number is chosen at random from Q is equal to 1, 2, 3 to 10. Find the probability that the chosen number is either a prime factor of 42 or a multiple of 3. So solution for question 5a. We have our Q, which is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we are asked to find the probability that the chosen number is either a prime factor of 42 or a multiple of 3. Let's find the set for all prime factors of 42 from the set Q. So all prime factors of 42 from the set scale, we have 2, 3, 7. Then let's find the multiple of 3 from the set scale. So all the multiples of 3 from the set scale will be 3, 6, 9. Now we are being asked to find the probability that a chosen number is either a prime factor of 42 or a multiple of 3. Probability of selecting a prime factor of 42 is P of A. And the probability of selecting a multiple of 3 be P of B. So the probability of selecting a prime factor of 42 will be 3 over 10. So we know that probability is equal to the number of events over the total number present, or let me say the sample, the total number of samples. And we have 3 prime factors of 42. So should we pick a prime factor of 42 from our set scale, we can pick it 3 times. So we can either pick a 2 or pick a 3 or pick a 7. So there are 3 events from this set when we are picking a prime factor of 42. Now when we are picking a multiple of 3, we can either pick 3 or 6 or 9. So here too there are 3 events of picking a multiple of 3. So our probability of picking a multiple of 3 is also 3 over 10. Now 10 is our total sample because we have 10 values in our Q. Now when we look at the set of prime factors of 42 and then the set of multiples of 3, we can see that we have 3 in both sets, which means that there's a probability that we'll pick a number and it will be a prime factor of 42 and at the same time be a multiple of 3. So then we can say that we have A intersection B, which is equal to 1 over 10. So the probability of picking a prime factor of 42, which is A, or a multiple of 3, which is B, is equal to the probability of A or the probability of B minus P into brackets A intersection B. And we know that the probability of A is 3 over 10, or in probability is addition, plus the probability of B is also 3 over 10, minus the probability of A intersection B is 1 over 10. So when we punch this on our calculators, we should have 1 over 2 or 0.5. So the probability of picking a prime factor of 42 or a multiple of 3 is 0.5. This brings us to the end of question 5a. So we'll be moving on to question 5b. So question 5b, if 110 base x is equal to 1020 base 4, find the value of x. So we have to find the value of x. It means we change both numbers to a common base. And in this case, we can change both values to a common base of 10, base 10. So we are going to change 110 base x to base 10 and 1020 base 4 to base 10. So we have 1 times x squared plus 1 times x1 plus 0 times x0. This should be equal to 1 times 4. So here will be 0, 1, 2, 3. So 4, 3 plus 0 times 4, 2 plus 2 times 4, 1 plus 0 times 4, 0. Now this will give us x squared plus x plus, so any number raised to the power 0 is 1. So 0 times 1 is 0. It's equal to 4 raised to the power 3 is 64 plus 4 raised to the power 2 is 16, and 16 times 0 is 0. So plus 4 times 2 is 8 plus 1 times 0 is 0. So our x squared plus x will be equal to 72. Now this can be written as x squared plus x minus 72 is equal to 0. So we have a quadratic equation. Now we factorize the quadratic equation to get the values of x. So we find two numbers. When we multiply, we get negative 72, and when we add, get positive 1. So when we list the factors of 72, we have 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36. So now when we pick 8 and 9, so 8 times 9 is equal to 72, and 8 plus 9 is equal to 17. So when we negate the 8 and we add it to 9, we have 1. So negative 8 plus 9 is equal to 1, and negative 8 times 9 is equal to negative 72, which is this and this. So then x squared plus x minus 72 equals 0 can be replaced with negative 8x plus 9x minus 72 is equal to 0. So now when we factorize, we get x into brackets x minus 8 plus 9 into brackets x minus 8 is equal to 0. Now we have x plus 9, x minus 8 is equal to 0. So we can say that x plus 9 is equal to 0 and x minus 8 is equal to 0. So we have x is equal to minus 9 and x is equal to 8. But then we know that a number base cannot be negative. Since a number base cannot be negative, then our x will be equal to 8 and not negative 8. So this brings us to the end of question 5. Now don't forget to like, comment, share and subscribe.